I'd like to introduce today's speaker, Nikhil Chandrapa from the Yugabyte Ecosystem Engineering team.
Thank you, Michelle. Thanks for joining. So my name is Nikhil. I work in the ecosystem engineering team at Yugabyte. We work on the integrations with some of the popular developer tools like Spring Framework, GraphQL, Kubernetes, and also we are responsible for building the drivers for YugabyteDB itself. Glad to be here. So today we have like a really good or a very interesting topic that we have, which talks about running Kubernetes operator on Red Hat OpenShift. Obviously, like if you're on the call, you might be like super interested in running a database workload on Kubernetes. Kubernetes these days is massively popular, right? So it all started with developing stateless applications. Now it's like it's like a lot of people are thinking of enabling databases on Kubernetes. So one of the important things when running a database on Kubernetes, right? So it's like some of the day two operations that you need to take care of running a database on Kubernetes, it actually changes from different databases for different databases, right? It kind of changes from one database to another. Even for Yugabyte, since it's a distributed SQL based sharded clustered architecture, so some of the day two operations that we have, like handling failures, rolling upgrades of the cluster, backup and restore of the cluster, all these things we are able to implement that using the Kubernetes operator design paradigm, right? So of late, Kubernetes operator has become super useful, and also it's become super popular. Like every database vendor or any stateful application vendor is implementing a Kubernetes operator so that they can bring in really good support for automating the management of their product. So in today's talk, we are going to talk about YugabyteDB Operator on Red Hat OpenShift. So how as a developer, you can consume the Yugabyte operator on OpenShift, and how you can instantiate the cluster, access the cluster. We are going to explain all those things in today's presentation. So in short, if you see this diagram, it's pretty straightforward how a YugabyteDB operator works. Currently, some of the operations we do support with Yugabyte operator is we support this like during the Yugabyte scaling or rolling upgrade or things like that. We take care of identifying the state of the cluster, whether there is already a major compaction happening or there is a data movement that is happening within the cluster and things like that, based on which we identify whether the operation is safe to proceed or not. So all those things are taken care within the Yugabyte operator. So to quickly get started, we have a custom resource definition that we have implemented. It's called YB cluster, which is responsible for monitoring the Yugabyte DB cluster itself. So we are going to be creating a Yugabyte YB cluster resource for instantiating the Yugabyte DB cluster. And once we create this resource, YB operator will take care of the entire life cycle of this resource. And underneath, whenever we create this CRD of YB cluster, what it does underneath is it's going to create two stateful sets for us. It's going to create a YB master stateful set. YB master is nothing but a coordination node within YugabyteDB cluster, which is responsible for leadership election of the RAF consensus protocol that we use for our distributed system, and YB server stateful sets, which are responsible for actually storing the data, and apps connect to YB servers for fetching the data or querying the data, right? On top of that, what we also provide is we kind of provide a management UI for each of the cluster that gets created, and each of them will be enabled with a load balancer. We'll just show you how all those things work in action next. So without I didn't have any more slides. I just wanted to directly get into the demo of the product itself, like YugabyteDB running on OpenShift. So and if you quickly go to the Red Hat ecosystem catalog, right, or the Red Hat marketplace, you will find the YugabyteDB operator there. YugabyteDB Operator is actually certified for running on the operator hub of OpenShift. So you can see if you already have OpenShift installed, you'll probably have a dashboard like this, the OpenShift Container Platform dashboard. Every certified Red Hat product will be available in the operator hub of OpenShift Container Platform, right? So we have already taken care of installing the OpenShift environment in our OpenShift platform in our GCP environment. So using that, using that we are accessing the container platform. And in the container platform, probably most of the users, I mean, all the operators or DevOps people of Red Hat OpenShift probably will get access to the operator hub where they can go ahead and install any operator they want, right? This is how you can consume any vendor's operator. So if you search for Yugabyte here, you will see a YugabyteDB operator. So I'll just quickly select the Yugabyte operator. It gives you a bunch of details like it is certified, it's provided by Yugabyte Inc., and also it kind of provides you the details of the repo where the Yugabyte operator is and the version of the container image that we are using. So the current version of Yugabyte operator, it is 9.0, it's in beta. So we are still, it's actually production ready. The reason we are making it 9.0 is we want to have we want to see this running in production, and as and when we see some of the advancements that we have to do in the cluster, we'll just then make it a 1.0 version of the product. So currently it is like a GA, it's actually production ready. So one thing that you notice with the Yugabyte operator is we support a CRD called ybclusters.yugabyte.com. This is the new CRD that we have implemented, which is responsible for reconciling the Yugabyte cluster itself. And there's like few supported parameters we do as part of the Yugabyte operator, like whether you want to enable TLS or not, what is the image that you want to consume, and things like that. And also we have few helpful links that we provide as part of the description. If you see how to get started, what are the ecosystem integrations we have, some of the real world app and the architecture of the Yugabyte database itself. If you're interested in understanding how YugabyteDB itself works and how the architecture of the Yugabyte works, you can check some of these documents. So as a developer or an operator who is trying to install Yugabyte on OpenShift, all he has to do is go to Operator Hub, search for Yugabyte operator, and click on install. So once you go and select the installation page, there's like a bunch of options that you can do. For now, I'll just deploy the operator on the default namespace. As I said, we are consuming the beta channel, and approval strategy I want to select as automatic so that I don't want any in future manual way of upgrading the operator whenever the new version is available. And I'll say just subscribe. What this actually does is this will OpenShift now will go ahead and create a Yugabyte operator pod in the default namespace. So if let's give it a minute, it will, once everything is done, it will show up. Let me go to the installed operator again. Okay, it still stays, it's still installing. Once the installation completes, we can take a look. Okay, perfect. The installation is succeeded. That's all it takes for the Yugabyte operator. So if you want to quickly see where the pod itself is running, I have my CLI, the OpenShift CLI configured against this environment. I'll just do OC get pods. We should see one of the Yugabyte operator pod running. So obviously, right, like whenever you instantiate, install the Yugabyte operator itself, a pod gets deployed. So this operator pod is responsible for maintaining and reconciling or managing the CRD we created. In order to deploy a Yugabyte cluster, all I have to do is let's just go to one of the installed operator, and you will see an option called create instance. all I have to do is just click on create instance, and I'll get a default YAML for all the things that I can configure within Yugabyte. So there's like few things that we can configure as part of the YB cluster CRD. I can specify the resources of my T server and also specify the resources of my master, and specify things like what is the version of the Docker image or the version of the Yugabyte image that I want to use, things like that. We can configure all those things here. And also there is another way of editing this. There is probably like a form or a GUI based. So GUI based is probably gives you a better UX experience. However, editing YAML gives you the more flexibility and also access to the entire set of things that you can configure with the CRD. So for installing Yugabyte cluster itself, what I'll do is I'll just go ahead and change this stack to the latest Yugabyte image that we have. The latest Yugabyte image is 220. We recently, like 15 days back, we kind of released a 2.2 version of the product, and this is the latest container for that product. And for our purposes, I am gonna turn off TLS communication between the components, like even for the master as well as the T server. And along with that, one thing that I want to remove is I want to remove the certificates because I'm not using a TLS enabled cluster. Okay, once everything's good. Okay, cool. And delete this, and then just say click on create. So once I say click on this create button, what actually happens is, so I'm gonna see a cluster called example YB cluster, which is of type YB cluster. Underneath this YB cluster, we'll go ahead and create those two stateful sets. Let's just see that in action, right? I'll go click on create, and right now, if I go to the example YB cluster is actually getting created in the default namespace. So I can go ahead and see the pods getting created. I'll say get pods -- watch. You can see all the masters and the T servers that are getting created as soon as I created the CRD. That's it. That's how simple it is for us to consume Yugabyte on OpenShift container platform. All you have to do is go to Operator Hub, install YugabyteDB Operator, and then you can start creating YugabyteDB instances. So by default, Yugabyte creates a RF3 or a 3-node Yugabyte cluster, which has 3 T servers and 3 masters. 3 servers are the ones where the data gets stored, right? So even if you want additional details of how Yugabyte itself works, you can go and take a look on a bunch of blogs and other videos that we have published. Okay, cool. Let's see if the cluster came up. But I can actually check the progress even here. I'll just say, I'll go to the stateful sets and see if my stateful sets are running. Okay, it says 3 of 3 pods are up, 3 of 3 pods are up. As I said, the CRD, the YB cluster CRD creates these 2 stateful sets. Okay, now I think the cluster is running. There's like few other resources that gets created as part of the cluster itself. Now, if I go and see the services that gets created as part of this, there's like few services that we create as part of the cluster. We create a load balancer for exposing the UI. As I said before, there's going to be an administrator UI associated with each of the cluster that gets exposed as a load balancer under YB master UI name. And also we'll have another UI which is responsible for admin or the metrics that when the cluster is running. If you want to access any metrics for that cluster, you can access that through the YBT server UI. Cool. Now Let me just quickly go to my installed operator, and I click on this, and if I see YB, you'll see that I have my cluster running. Okay, perfect. Okay, now as I said, it kind of also enables a master UI, right? Now let's go ahead and quickly see the master UI. The master UI is running on port 7000. All I'll do is open a new page. Sorry, I'll take the load balancer IP address and select the port 7000. Perfect. This is the admin UI for every Yugabyte DB cluster. Like if you create another Yugabyte cluster, you'll see one more master management UI. So what it provides is that it kind of gives you a bunch of information, like it provides you like details of the replication factor. Replication factor is nothing but how many copies of data you want within Yugabyte. Like by default, it creates a RF3 cluster where you'll have one master and two followers. You'll have 3 copies of data. And right now, as I said, we have a 3-node cluster. It just shows 3 nodes, and we can go and take a look at some of those things as well. Okay, and also it kind of gives you like the Yugabyte version here. Okay, sorry, all the nodes are specified here. If you see, we have one leader, the YB master one is the leader, and other 2 are the followers. Okay, fantastic. And another thing that I wanted to show is like to logging into the cluster itself using kubectl or the Openshift CLI, the OC CLI. So all I'm doing is I'm exec into the YBT server pod and YBT server 0 pod, and I'm gonna instantiate a CLI called YSQSH. That is nothing but a SQL CLI that we supply out of the box. The way that you log in to YBT server or one of the available T servers is through YSQLSH. So I'm just SSHing into or executing into one of the pods of this cluster. So I do this, and this gives me like the CLI for running SQL statements. For now, I already have a data set that I have loaded before, since I'm reusing some of the PVs that gets associated with the old cluster. So I'm going to use the same things. So I have a database called Northwind database here. So I'm going to connect to the database. It says, okay, I'm now connected to the Northwind dataset, and I can do like a quick description of all the tables that are available. So these are tables that are created as part of the Northwind dataset, and I can go ahead and query some of the one of the datasets you want. So we have a blog that we have published, which pretty much talks about how the Northwind dataset actually works. I think, yeah, this is the one. So which kind of walks you through how to set up a Northwind sample dataset on YugabyteDB. I had run through these steps before, and some of those data are already available as part of the same disk, and I just recreated a cluster to use the same disk. So if you see, I can just do a select star from this customer, and I can see the data from data. This is as simple. This is like a quick and easy way of getting started with Yugabyte. And if if you have any workloads that you want to quickly prototype, and which requires like a transactional way of accessing data on an OLTP database, and also it needs to be scalable. The Yugabyte is a very easy solution, or a perfect solution for you to get started on Openshift. Cool. That's all I had as part of this demo. I just wanted to quickly do a demo of how to get started on Red Hat. I think this gives you a brief of how anybody can get started on OpenShift with Yugabyte. any questions out there, feel free to ask. I'm happy to answer any questions on Yugabyte operator on OpenShift.
Hi, Nikhil. It does look like we have a few questions in the queue at this time. The first question is it possible to specify the number of T servers in a given cluster during creation?
Yeah, that's a good point. I actually forgot to walk you guys through all the options that our operator supports. Let me quickly go back to the operator hub. So if you search the description of the operator itself, so we kind of provide you a bunch of supported parameters. So every CRD that you create, you can specify number of replication factors, like as I said, number of replica copies you want, and also specify the pod count of each of those clusters. So obviously, like by default, it's 3, and if you want to have you cannot reduce it less than 3. It will be, you can increase it, like say as starting off you want a cluster of 5 node cluster, you can just specify that as part of the T server pod count. The way you do it is, let me quickly go to the installed operators and I'll show you while creating a new instance. So if you go and see here, I'm specifying the number of replicas as 3. All I'll do is, for the T servers, I'll just say replica as 5. This will go ahead and create a 5 node YugabyteDB cluster. Hopefully that answers the question.
Okay, there's another question in the queue here. I'm not sure if you answered this in the previous one, but I'll ask it anyway. How can I scale the number of T servers in a cluster?
Oh yeah, and the same thing, like as I said, probably like my previous answer answers this as well. So you can specify the replicas here, and also you can specify the resources that each of your pod wants. Like you can specify for some of the production clusters, we expect the number of CPUs to be 4. So since it's a demo purpose, I have kept the CPUs as 2 itself. And few things, other things that it kind of gives you as well. It's like you can specify the default memory limit and things like that that YugabyteDB supports. Short answer is yes, we can specify the number of T servers by specifying the number of replicas here.
Okay, there's one more question in the queue today. This question is, how will applications connect to the YugabyteDB cluster?
That's a really good question as well. So let me go back to the number of services that every YugabyteDB cluster kind of specifies, right? And the services that we kind of enable out of the box. So if you see here, we kind of have two two different services that we expose apart from the UI, apart from the load balancer services, right? The YB master and the YBT server. Like any application that is trying to connect to Yugabyte will use the YBT servers service. So you can specify something like I think we pretty much saw this here, right? Like if you see here, all I'm saying is I want to connect to one of the T servers and the name of the service and the namespace where that service is actually running. So this is the kube DNS name that you'll be using for connecting your apps. All you can, there's like 2 different drivers Yugabyte actually provides. If you don't know what Yugabyte, the APIs that Yugabyte supports SQL API as well as CQL API. For SQL API, we prefer you to use the internal headless service so that it can load balance across available T servers because for SQL, the JDBC driver is not yet cluster aware. That's why we want to have a load balancer so that it can load balance across all the available nodes. For CQL or YCQL, which is NoSQL based data access, we call it as cloud query language, which kind of provides transactional way of accessing NoSQL data. So for that, we kind of have a cluster aware and a topology aware driver. So all we specify is one of these T server DNS names, and it takes care of figuring out the topology of the entire cluster and making connections to all the available T servers. So whenever the cluster scales up or scales down, the clients will automatically know they have to update the cluster topology. And also the CQL clients are kind of data aware, which means they know where the data actually resides, and they can do something called as a one-hop fetch. So those are the two types of drivers we support. The way you connect to some of those drivers are connect the apps to Yugabyte cluster is using by specifying one of the T server kube DNS names.
Okay, that concludes the questions from the open Q&A.
Fantastic. Thanks a lot, everyone. Thanks a lot for joining.